in the presentation this afternoon, I'm going to try and hit all these guys on the high points. I'm going to try to explain who the hell PeterKrey is and why. Go through the context and overview for my slides. We're using cloud computing on the enterprise side as what I call point of view, or to set the perspective on this, because it's very hard to understand the importance and criticality of this automation stuff until you've actually tried to go and built a cloud. And then we'll go through a whole bunch of these other points here, some metrics, my wisecrack of what the new Grand Canyon is, network infrastructure as code, I'm stealing Larry's stuff, what I call the Shawshank Redemption, that's going to make all the vendors really mad at me, and how I see OpenFlow enabling. The really key thing here for me about OpenFlow is how it's enabling applications, not necessarily all the low-level infrastructure stuff. And in the end, we'll do the Q&A, and I'll do a quick, what I call killer CapEx and OpEx, which is the real context. So who the hell is PeterKrey? Well, I want to thank everybody for this opportunity to speak. Whoops, where did my cursor go? I'm in big trouble now. Okay. Guys, hang on one second, because I can't work my presenter tools without the mouse. Yeah. To scroll that stuff. Oh, sorry. Okay, thank you very much. Sorry. How do I do that? My apologies. Okay, sorry. All right. That just gives me doofus credibility here for doing the wrong thing. Okay. Just one quick wisecrack after Larry speaking. Now I know what it's like to follow Frank Sinatra in Vegas. He did a really good bunch of slides there. So PeterKrey's been an independent consultant in financial services about 8.5 years. My prior professional background has been enterprise infrastructure in a couple of major Wall Street firms, all the way up to a CTO type role and CIO direct report, etc. Right now, the majority of my clients are those enterprise CIOs and CTOs and their direct report teams. On occasion, VCs, private investors, serial entrepreneurs, etc. And I'm constantly on the hunt for things that I call their emerging disruptors. And the whole theme of my business is innovate to save. The concept and influence of OpenFlow, in my view, rocks. I'm a huge fan. And in addition to OpenFlow, participant in other things, one out here in the Valley around OpenCompute, and another one with the Rackspace guys around OpenStack. For my business and for my clients, I focus exclusively on people that I call thought leaders or enabling disruptors. Typically, they're startup founding teams, only CTOs, heads of engineering, development, etc. My wisecrack is those that actually do things. I don't do any business with tier 1 hardware or software guys. It's not my business model, and a little bit too much conflict. The key product of what I do, and you'll see in the context of the slide deck, is ID and due diligence of disruption. All these things are delivered in terms of working proof of concept projects. So I am not a comic book jock with PowerPoint. And all these things are with significant OpEx and CapEx impact. Anyway, my sense about OpenFlow is that it's completely inevitable and probably unstoppable. I'm very, very gung-ho on it. To me, it is the closest thing to the early days of things like Linux. So anyway, it's reminiscent also of the write once, run just about anywhere thing. Today, my focus is going to be not about the super techie or what I call the low-level OpenFlow stuff, but I'm going to speak to you like you're a room full of CTOs and CIOs. So it's going to be a bit more high level about what OpenFlow enables and how this has let the innovation genie out of the bottle regarding proprietary networking. Okay, so here we go. So quick question, what is cloud? If I ask 10 people, what is cloud computing, I get about 15 different answers. They'll include SoftLayer, Amazon, Rackspace, Cloud.com, Terramark. It'll include Azure, VMware, vBlock, and I don't know if Acadia is still alive. And basically enterprise-based virtual machine farms that are kind of almost a cloud. And then last but not least is what I call the quasi-open source cloud foundry. For the last couple of weeks, you've probably also heard about OpenStack now running and supported with collaborations of HP, Dell, and Ubuntu. That's pretty cool. Overall, when it comes to cloud, it's a very poor signal-to-noise ratio from the commercial side of things. To me, it's one of the most over-marketed and distorted things since object-oriented program back in the, I guess, the 80s. So for those of us who remember that. To me, it's also analogous to the old Saturday Night Live joke. I don't know if anyone in the room is old enough to remember Shimmer. It's a floor wax and a dessert topping. Good. A couple of people remember that's good. And also for those beer drinkers too, it's like the Miller tastes great, less filling ad. If you look at this slide, I'll give you a quick hint. There's 6 eye candy what is cloud diagrams up here. And in terms of what I want to talk about today, one of these is actually correct. Anyway, what I'm about to say, my next slide is based on 25 years of enterprise experience. The following slide is really the only thing that I've seen as a succinct and accurate definition of what cloud computing is. Cloud computing is not enterprise IT. For the upper right, enterprise... I'm sorry? It's actually 3 of my colleagues that used to work with me. Their own sunglasses, their identity was changed to protect the innocent. But anyway, enterprise thinking is really around the blind leading the blind. Cartoon includes some colleagues whose names, like I said, have been changed to protect the innocent. Whether it's internal or external, first time ever enterprise customers and developers who have ever had choice, freedom, and control. First time in my career, a customer could look me in the eye and say, if you don't do it, I can get it myself. It's all about no IT people, no process, no bureaucracy, no business cases, no governance, no standards compliance, not 9 months of delays. With true cloud, you get what you need in seconds to minutes, not months to quarters. Cloud is also a dislocation of excess process and delay, and the key thing is it's a replacement of all of that via automation. It's radically changed what enterprise customers expect is what's possible, how much it costs, and how many minutes are required, not months, to actually get something done. Also, when I'm out here in California and I visit with a lot of startups and early stage companies, they no longer have $10 million IT infrastructures. They have one guy. Everything's through external cloud. It's pretty amazing. So it's no longer about yes or no, and we'll get back to you. It's about how fast, how cheap, and having freedom. For the rest of the slide deck, please think about cloud as Enterprise 2.0. Key question here is, what does it have to do with networking? And to my eye, everything. So when I stole the slide from the guys on the Dev to Ops team. To me, just like open source, I'm a huge fan of the concepts around Dev to Ops. Integrated Dev to Ops culture and automation removes, God bless you, the chuck it over the wall mentality and the practices of the past few decades, and connects and integrates development with deployment and operations. That's actually pretty cool. Due to my visibility into both enterprise East Coast and West Coast technology, engineering, and operations, to me, these photos resonate and characterize things. In comparison, the East Coast approach really feels very manual, overly complex, low-tech, antiquated, inconsistent, error-prone, and difficult to repeat at scale. And I say that with the wrinkles and gray hair of having run enterprise IT globally for large investment banks. Before I did that, I looked like I was 14, and now I look like I'm 70. And so, thank you. But the truth of the matter is, it's interesting how when you make large-scale global changes, how much disruption and unreliability you get due to change. Traditional enterprise technologists are highly resistant to innovation, remain stuck on tier 1 commercial vendors. I think they suffer from what we call enterprise muscle memory. They've been repeating the same range and pattern of motion for so long, aka process. So for so many years, they're approaching being handicapped and unable to leverage positive change and innovation. So if a corporate psychiatrist were to use a left photo in diagnostic as like a Rorschach, I think it's called the Rorschach test, sorry, the ink blots. Yeah. So as the Q&A says, hey Peter, what does this photo remind you of? Left-hand side reminds me of enterprise IT in the old days. It also reminds me of a sarcastic wisecrack, a client of mine who's a global CTO. We always used to joke coming out of meetings with our boss who's the global CIO. Enterprise IT puts the no in innovation. Think about that for a second. It actually, when you're on the other end of that, it's not as funny. So after a session, I was asked, hey Peter, what does the right photo remind you of? I'd say it reminds me of the West Coast startups, entrepreneurs, large-scale Web 2.0, places like Google, Facebook, Amazon, and others. So that's why the left photo makes me think enterprise. While the West Coast feels largely automated, highly repeatable and consistent, highly receptive to adopting and advancing innovation, lots of open source, vendor-agnostic hardware, tons of automation. So the question again, what does this have to do with networking? Cover story from Information Week this year. good news is there's a set of CIOs actually are starting to get the joke. They're starting to realize that true cloud drives opportunity, not challenge. And there's a very emerging self-awareness. IT indeed is too slow. Very interesting that such a story would make the cover of Information Week. And that cloud computing is all about 100% automation and self-service, 0% bureaucracy and process. An interesting example, I've heard through industry grapevine that one of the above is way more engaged and impactful than his quote may indicate. Might be the guy in the middle of the slide, I'm not really sure. Rumor has it that they did a 1,250 VM instance running 10,000 cores on AWS. It was provisioned via Chef in under 45 minutes, and it only cost them $1,000 an hour. Now, when you see some of the multi-billion-dollar IT budget slides coming up, $1,000 an hour is pretty damn good. And there are also discussions underway to expand this to 25,000 cores and 50,000 cores. The only thing that's limiting this is that the company that's doing it is American Express card ran out of money. But anyway, you'll be seeing some stuff coming out this year. So once again, what does IT too darn slow have to do with networking? In my view, it has tons. So this slide is a summary of a bunch of metrics we put together to try to get enterprise infrastructure folks to fairly characterize and measure cloud. So how does one establish consistency and fairness within an enterprise when trying to do cloud? Well, the biggest issue is cutting through all the vendor qualitative marketing noise and establish a way more quantitative approach in metrics. Most traditional enterprise clouds are really virtual server farms in my view. They're entrapped within a traditional enterprise manual process in government, very significant cost premium of being 100% tier 1 and proprietary product based. So one solution to get everybody on the same page is to speak directly to their customers, developers, end users, in our case traders, quants. Ask them why they like external clouding so much. And the above generic example is a result of doing such an exercise. The idea here is to ask a bunch of questions and characterize them in these metrics. What are the degrees of completeness of your automation? How exactly how repeatable and precise are your underlying processes? Not. How long does it take to actually get something done? Minutes, hours, days, weeks, mostly months. How much of the overall infrastructure and provisioning management is actually automated, and to what degree? Less than you'd like. And how do all these compare with external cloud providers such as SoftLayer, Amazon, Rackspace, Cloud.com, and the upcoming torrent of OpenStack external implementations? And again, not to sound like a broken record, what does this have to do with networking? Tons. The above bullet points summarize or summary and synthesis of all the sources listed on the bottom of the page. In order to produce something that was vendor independent and kind of truly open, we also included things from a good mix of geek sources and business sources such as The Economist. To make a long story short, most popular clouds are 100% self-service, 100% automated, they're vendor agnostic, they're open and process-free. The most popular are best depicted via the Hertz Gold Card Rent-A-Card model. With a website and a credit card, I find my name on the board, go to the parking spot, get in, and drive. And when I'm done, just bring it back. There's zero process and bureaucracy. Either a command line script or a couple of GUI clicks, I'm free to choose whatever car I want. It takes seconds to minutes, not months. Sysadmins and developers have autonomous command line and REST API access, which to my eye means language and tool independence. This facilitates development of vendor-neutral automation, which is absolutely key. The only thing between me and what I need are a minimum of 2 and my credit card number. Giant hint, networking is a really big key above. All right, I'm going to go through this one really fast in only like 10 seconds. This was another synthesis, but what I wanted to use is to point out that my perspective, the following slides, are all about infrastructure as a service, not the higher level. But the higher level stuff, it also applies the same way. Overall, there's lots of cloud thinking in terms of the OSI stack. I'll show the guys in the next slide. This was a sample from the guys at OpenStack. It provides an interesting comparative positioning of various external cloud offerings. Like lots of Amazon AWS, great automation command line tools, again 100% self-service. I'm going to keep saying that over and over and over. And to my eye, it's the ideal target basis for comparison. It also depicts that enterprise IT end users and developers are no longer in prison. They now actually have choice. So if enterprise IT doesn't respond, we're going to be dinosaurs pretty soon. Reason for me going down this path is to ask everyone, despite what this looks like, comprehensive infrastructure as a service, PaaS, SaaS, analysis of cloud, except for software, again, what's missing here? And so these are two different points of view, one from dev to ops, the other one more OSI-like, being as, PaaS, and SaaS approach. The network is clearly missing. How the heck can anybody enable all the 100% automation, 100% self-service, not enterprise IT and user requirements without enabling automation and standardization of things down in the network layer? I can't figure that out. And how the heck can you enable applications, corresponding application infrastructure, storage, etc., all to be free from static location-dependent configuration and implementation details without some level of indirection and virtualization? I haven't been able to figure that out yet. And without enabling language-independent automation interfaces such as REST, that's been talked about a couple of times, big fan of REST, how the heck can anything be automated in a vendor-neutral, language-neutral, standards-based way? In summary, what the heck about the network? Well, to my eyes, this is a giant gaping hole. So here comes the beginning of the sarcasm. From an automation standards point of view, to me, networking is the new Grand Canyon. The reason I show 4 pictures up here is to show a different perspective. No matter how I look at this, current thinking and closed proprietary technologies and enterprise networking are the Grand Canyon. Getting across this gap is pretty much impossible. And in order to produce cloud automation, we have to go beyond command line interfaces and enable developer APIs to improve access to 3 core components. From our experience, from my own personal experience, the server hypervisor part is pretty straightforward. With the exception of VMware, very, very narrow access to the full hypervisor API. Things like XenServer and KVM are actually pretty good. XenServer experience through XML, RPC, and Python, working pretty well. Just about all the functionality is fully accessible. KVM, there's an organization called overt.org. I think it was about 2 weeks ago it was just formed. It's a full gauntlet of developer tools and API access. It's got a really good future. I think IBM has dedicated 80 developers to completing the current KVM environment, including developer tool access. Storage. Traditional enterprise storage, again, very limited narrow API, very closed, very proprietary. However, mountable open storage, things like Nexenta, Gluster, just purchased by Red Hat, and others, have a fairly open API and very enabling for automation. The key here are also distributed object stores and NoSQL technologies. They are wide open, no problem with API access via REST and command line. And things like Swift and OpenStack, Gluster, and coming out of the HPC community is something called Ceph. They're wide open, piece of cake. However, networking. The functional developer gap, really to my eye, is the size of the Grand Canyon. It's a huge problem. Too closed, too proprietary, too limited. And historically, and I'm old enough to actually say this, there's been a very low rate of innovation. Core networking issues are not just about automation and enabling developer access. It's also the ability to isolate application and middleware layers from traditional network operations and configuration, what I call stickiness. Enterprise cloud is currently locked in due to lack of open standards, virtualization, and what I call the Teflon of the enterprise cloud, which is the new network. We need to isolate applications and middleware from static configuration issues that inhibit mobility. So enter OpenFlow. I'm thankful that OpenFlow was started and exists. But to me, by far, one of the most interesting and emerging, potentially enabling networking changes I have seen in many, many, many years. The changes on the software side of things via OpenFlow. Started back in 08 and 09 as part of Stanford Clean Slate. You guys probably all know this. A lot of prestigious schools involved, and thanks to this group, we're here today. To my eye, the most impactful and disruptive aspect of OpenFlow is it's usually enabling open source software and potentially blasting through tier 1 networking, what I call the Berlin Wall. Sorry, guys. And enabling unrestricted open source development and innovation. And oh yeah, it also enables a whole new genre of standards-based, vendor-independent networking hardware as well. So I always tell my clients and my colleagues, heads up, genie's out of the bottle. You guys saw this before. I'm going to skip over this one. I think the guys that already presented gave you some really good meat on this one. This one is kind of more interesting. OpenFlow components. For me, what usually strikes me about OpenFlow is what it makes possible and what it enables, not the hyper low-level details of OpenFlow itself. I think of OpenFlow as an open version hardware layer for networking. It reminds me of how ARM enables mobile and tablet technologies, except OpenFlow is fully open and accessible. Per the above, there are numerous and growing OpenFlow software switch options, numerous and growing OpenFlow physical and virtual hardware options, and a lot of growing OpenFlow controller options. Yeah, at the hardware and platform level, it is complex and powerful, but at a higher OS and resulting application level, it's hugely enabling. And this is the part that really has me the most excited. Luckily, I've worked with enough talented software developers in order to say, wait a minute, where did all these projects come from? How come there are so many open source projects that run on top of OpenFlow? Is this true? Well, I've worked on enough enterprise cloud projects to testify that manual, people, and process-oriented, non-automated operations are limiting and imprisoning. In a nutshell, OpenFlow is enabling an awesome batch of open source projects. Stole some photographs here from the Shawshank Redemption, just trying to point out its additional sarcasm. It's a Shawshank-like escape from traditional IT, particularly around enterprise networking, from both the technology and the operations perspective. Not only enabling switch hardware independence, but also a growing range of software-defined networking tools and open source projects. This is absolutely key. On this list, I've included things like OpenFlow Hub, consolidated site for all the OpenFlow apps. Floodlight, Java-based OpenFlow controller. Beacon, from Stanford. It's a fast, cross-platform, modular Java controller. Supports both event-based and threaded operation. Knox, folks have already talked about that this already today. But to me, it supports concurrent application plugins written in Python and C++. Simplified, writing network control software in C++ and Python. Open vSwitch is a multi-layer virtual switch, available under Apache 2. Currently supports stuff like XenServer, KVM, VirtualBox. RouteFlow, virtual IP routing and forwarding services, runs on Knox. Interesting. Maestro, guys from Rice University and National Science Foundation, a Java-based OS for orchestrating network control applications. Nettles is from the folks at Yale. Sorry, I could not find a logo for that. What's really interesting to me is something called Frenetic. So let's look at a couple of code samples, not only from Frenetic, from some of the other stuff. So per Wikipedia, Frenetic is a domain-specific language for programming OpenFlow networks. It's kind of embedded or enshrouded in Python. A domain-specific programming language that allows network operators, rather than manually configuring each connected device, to program the network, as they say, as a whole. Frenetic is designed to simplify OpenFlow and Knox programming and its potential complexities. Kind of like that. In particular, it introduces a set of purely functional abstractions that enable modular development, higher-level programmer-centric packet processing, on and on and on. Frenetic is functional reactive programming. Pretty cool. So what really strikes me here is, as a developer, I can do all that software-defined networking in Python. That really rocks. So as a developer, I may not only be getting free from proprietary, closed, non-automated, but I'm also getting more open. Let's take a look at another one. Beacon. So what if I'm not a Python developer and I only know Java? I'm sorry, it's not clear. There's a screen snap. Resolution problems here with the projector. On the left-hand side is the left column is a sample of Java code. On the right-hand side are some XML files that are used for Spring and Equinox. Wait a minute. You mean I can use the Spring developer framework and Equinox OSGI as an app server for network programming? That is pretty impressive. So hold on a second. Do these things really only use Java and Eclipse and Equinox? Well, for me, I also see the Spring XML configuration files. I quote Mel Gibson in this, and from Braveheart yelling freedom. Okay, so what else is supported? So far that was Frenetic and Beacon. The other thing that impressed me was Knox. Yeah, it's a low-level thing for network OS programming, but it's also an open-source OpenFlow controller. It leverages a switch abstraction layer. It gives me basically a network operating system. But what blew me away is I can write these components in C, C++, and Python. The other thing that blew me away is that their API leverages Boost. I've been using Boost for 10 years. So yet a more amazing use of these traditional application development tools for software-defined networking. I haven't seen anywhere in the sample code where I have to be a low-level, chip-level networking geek. It's all application-level stuff. To me, that kind of hit me home. Infrastructure as code for the network. What the heck does OpenFlow, open source software, Python, Java, C++ all have to do with the impact of the data center? Man, it's really simple. It's a bullseye on the Innovate to Save radar, what I call my Innovate to Save satellite system. Borrowing heavily from the guys that are the co-founders of OpsCode, Jesse Robbins and Adam Jacob. And by the way, we owe Jesse congratulations today. He got stuck in Boston. He's being presented with one of the TR35 awards at MIT. So Jesse, congratulations, buddy. OpenFlow is a giant enabler of infrastructure as code, in concert and collaboration with automation-enabling tools such as Chef, which underlying language is Ruby, and the highly innovative world of open source development finally has been connected with the static, near zero rate of innovation, from my point of view, around the limited network world. In my view, things that are at the application layer on top of OpenFlow are potentially huge. Finally, the rate of innovation and span of thought leadership here can empower networking world is potentially unlimited. To further borrow from another industry thought leader, from James Hamilton up at Amazon, who unfortunately could not make speaking at the event this week, his blog site has a really good wisecrack. It's like networking is the new mainframe. So when I look at network as code, I kind of look at things in the following. How do you describe and capture network infrastructure as code, and how potentially disruptive is that? Well, by enabling open, standards-based OpenFlow, software not hardware, at the control plane, networking innovation can now leverage the following. It's enabling a series of very powerful capabilities analogous to software version management, build bill of materials, and dependency analysis. So I can actually think about writing network configurations with an x.y.z versioning system. I've never seen that before. Just like we do software builds for analytics libraries or trading systems, I actually have versioning configuration control. I get to translate and apply software development tools, version control, build management, and other methodologies to network function descriptors. From a developer perspective, generating and managing infrastructure configs and state management, analogous to application build and version control. The other thing that blew me away here is when I talk about x.y.z version control, I also see it's 100% repeatable and automatable with tools like Chef, Puppet, CF Engine. So in comparison to server configuration management, hypervisor development tool access, open storage API access, enterprise networking really is the new Grand Canyon. The gaps are huge. We very badly need to evolve and develop. This has, for many, many years, been innovation starved. I'm really sorry for the eye candy here. About 2 o'clock in the morning, I tried to come up with all the logos sprayed across the periodic table. So I'm just going to kind of read you through this. The idea here is OpenFlow is fundamentally enabling by connecting two previously dissimilar, unfamiliar worlds. From my perspective, OpenFlow can be viewed as a periodic table for networking. It's analogous to chemistry. It's impossible to fully anticipate the expected total combinations of individual elements or software-enabled components into networking compounds that can emerge over time. My key message here is to highlight this is the first time two previously separated technology worlds have finally been connected and potentially enable a new, what I call multiplicative generation of innovation. For example, when Python became a mainstream tool many years back, any of us envisaged OpenStack or any of the large-scale functionality of Google? No. When Java first hit the enterprise developer world back in the mid-90s, did anybody envisage the Java-based big data innovations such as Hadoop, developer frameworks such as Spring, and war-based app server models such as the OSGI Equinox app server? To my eye, OpenFlow may also enable a new genre of hybrid capabilities, among all of these being the connector between the two worlds. A couple of examples from the left-hand side here. Java JVM-enabled languages such as Java plus Python have created Jython. Java and Ruby have created JRuby, JavaScripting and Groovy. Sorry, I didn't name it. and a new generation of languages such as Scala, Clojure, and others. And as a sidebar, on the bottom, I've also added the OpenStack logo down on the bottom. Would love to see more integration on a more formal basis there as well. Reason for this is with OpenStack, we really do need more formal integration and collaboration. I am aware of Open vSwitch and Quantum, but for me, they really kind of focus too much at the NIC level, so I'd like to see and know more about how OpenFlow and OpenStack are collaborating. If there's anybody in the room that knows more about this, please, at the end of the session, I'd love to talk to you. And thinking like an ex-HPC grid geek, given a cloud of guest OS VMs, I'd also like to see Monte Carlo-like simulations of software-defined networks. So for the first time, I can actually run software simulations of how something's going to be defined before deploying it. That's pretty cool. So in a nutshell, describing and capturing network infrastructure as code at the OpenFlow app layer is hugely disruptive. James Hamilton also did a really good slide on the hardware side of things. I could talk for another hour about this, but I'm just going to touch on it for a minute. The other massive vector of disruptive force here is the hardware side. With this topic alone, James frequently refers to current networking hardware as the new mainframe, making some fascinating comparisons of current network switch confinement and proprietary nature of today's mainstream commodity x86 servers. The two columns on the right side kind of go through a side-by-side comparison. It's amazing, looking at chipset logic, x86 being open, switching stuff being proprietary. The system software, open versus closed, and the key notion of application stack clearly summarized by words as closed, proprietary, and confining. I think James really hits the nail on the head. In the end, the essence of what OpenFlow enables here is change from this kind of confinement. So what if software-defined networks were thought of and measured similar to clouds? So Kyle and I were working on this in preparation for the summit. We took the cloud metric slide that we did before and said, what if we could do something like that for networking? So what we did is we started with that original slide. We came up with these 4 or 5 initial categories based on questions like the following. How long does it take to create and implement a new tenant virtual network? Is it minutes, months, weeks, years, decades? What's the overall flexibility of the network's topology? How open and easy is access to automation and developer tool interfaces? How open and language independent are those interfaces? It's my favorite one. How ergonomic and efficient is deploying new software-defined networking-enabled applications? In a nutshell, we're throwing this matrix out as a straw man starting point. It would be great to collaborate with everyone here and further develop this. All right, so 9,000 slides ago, I was supposed to be talking about data center impact. Well, beyond automation, if I were to talk to a room full of CIOs and CTOs, I would have been thrown out by now because I haven't talked about OpEx and CapEx. OpEx and CapEx impacts are potentially huge. Via hardware standards, a positive categorization of commoditization, and automating. It's really difficult to get industry colleagues and enterprises to disclose what their networking OpEx and CapEx percentages are, and so I'm not sure how to approach this. And not a whole lot that's public domain from places like Gartner and Forrester. So let's kind of put this together, making a quick matrix based on the pie chart and some quick assumptions. I would believe it's not unusual for most enterprises to have 20 to 30% of total IT CapEx and OpEx consumed by networking. The bottom right list gives some very interesting ranges based on some very simple arithmetic about potential OpEx and CapEx save. In my Wall Street career, I've worked at places, their IT budgets were on the low end $1 billion and the median $3 billion. And so based on this arithmetic, if it's 20 to 30% of your total, and we can automate it and standardize it and make it much more repeatable and much more consistent, some pretty substantial savings. You can come up with a project that has a 3-year save of over $1 billion, someone's going to listen to you. So in the end, yeah, I think things like OpenFlow lay the groundwork for some extremely serious OpEx and CapEx. All right, in summary, everyone looks like they want me to just shut the hell up and get out of here, so here's the summary. To my eye, IT is way too slow, so automation is key. OpenFlow is the first truly interesting, innovative, and disruptive networking idea in a very, very long time. OpenFlow, software-defined networks, and open-source networking apps are potentially huge game changers and enablers. OpenFlow is also enabling switch hardware standardization, open developer access and automation, and beginning to bridge the network Grand Canyon. Connection and integration with current developer tools and languages, application server platforms, and others connects and enables two multiplicative technology worlds for the very, very first time. I think this is really going to be key. Networking infrastructure as code is a killer app as far as I'm concerned. Potential CapEx and OpEx impacts are huge. Multi-billion-dollar saves, yeah, you'll get people's attention. Must also heavily collaborate and integrate with other open source projects like Git, Chef, OpenStack, and others. Networking can't be viewed as something alone. It's got to be stitched together. Hopefully, OpenFlow will also facilitate the creation of something like an open network compute a la Open Compute. So myself and some colleagues were very involved with the guys at Facebook around Open Compute hardware. We'd love to see the same thing happen with networking. In the enterprise, security models are also very, very important. They must be defined, implemented, and integrated. There's no way you can, in an enterprise, have unsecured, unaudited, unlogged access to all this stuff, but to me, that's pretty easy blocking and tackling. Would also love to see clarification and improvement of OpenStack collaboration at project level. And last but not least, anyone in the audience, unfortunately not a lot of people from financial services, don't complain about the gaps in OpenFlow. Roll up your sleeves, participate, and contribute. All right, finally done. It's 4 o'clock. Everyone can resume consciousness. Any questions? Sure.
You mentioned the chip vendors like Broadcom and so on. Elias Hatem, EMC. You spoke to the chip vendors that it's not so easy to integrate and they don't have good APIs and whatnot, unlike the Intel chipsets. Can you give some updates in case they kind of embracing the technology and what they will be doing toward it?
So due to non-disclosure limitations, let me just say the following. What I've learned from Open Compute is all the chip vendors from Intel, AMD, they license reference designs. So at the end of the day, we're all buying the same reference design with different decals, bezels, and a couple of chips. I doubt that networking is that much different. So I think over time, through third parties, such as the tier 2 switching people, contract manufacturers and ODMs, I think you're going to see a lot more openness in the hardware coming up. And if there isn't, we'll help you do it. Sorry.
No. So
I'm sorry, you've asked too many questions today.
Yeah, I know, I'm running out of time. So in the history, I always thought, so before I joined this room today, I thought I'm an engineer. Now I ended up in the management track. The same question popped up if I seen the way how you program network devices now. And I think in my whole history talking to all the networking engineers, they have no clue what you're talking about. They have no clue about Python, about C++, about all this JavaScripts, whatever. The same happens to me. So the question is, how will you bridge the gap to a normal guy which is just maybe configuring BGP or OSPF about the operational guys? So do you expect them to say, debugging on code to figure out what's happening in the network? So I'm a little bit lost in between. So originally I thought the idea brilliant, but now I'm a little bit in question because if it ends up, I have to become a programmer to operate my network, then I don't know if maybe I should go to retirement or something.
Two-part answer. I'm clearly not the youngest person in the room, and if I can learn Python and Ruby, I would love to hear the list of excuses why other people can't. Number two, when you look at anything that's new, so if you go back to the old days of mainframes and mini computers, people were going to client server. For a while, everyone banged their head against the wall trying to figure out how to make client server work on the mainframe or on the VAX or whatever. The key idea here is at some point you can't do that. And so when you get another wave of disruption or something that's really new and really game-changing, you sometimes have to start fresh. And so trying to get people that are accustomed to using runbooks and clipboards and whatever, teaching them Python or whatever, I don't know, God bless them. If they can learn it, we'll hire them. But I think it's going to end up being something new. Just like the prior shifts and prior technology chains, That doesn't mean the old stuff's going to go away. It means it's going to quiet down, it's going to level off, it's going to go into steady state. All the new stuff's going to flow towards the disruptor.
I'd also like to make a comment on that. If you think in large-scale network engineering teams, there's usually a group called the tools team that builds the tools, that build the provisioning stack for your networks and the tools to manage and monitor. Guess what those guys are writing in? Python, Perl, Ruby. So most network teams have coders in there. And most of those guys, in some places that's a complete split, some places some of the network. Usually it's a bad idea to have a tools team that doesn't understand networking, because you tend to get non-functional tools. So my guess is most networking teams do have folks who know how to write code in them anyway. It's hard to do the business without it.
Other questions? Sir?
Great presentation. I'm a true believer, so Stu Bailey, Infoblox. But I do have, so this is in the spirit of just trying to ask hard questions in this room because we get asked from outside.
Go for it.
I like your analogy to the Web 2.0 stuff. Again, this is a little bit related to my question in the previous session, which is, as a business driver, it's pretty clear you had a lot of consumers who wanted Web 2.0 apps, and it's driving it. As you pointed out, clearly the OpEx savings are there in the enterprise, but the enterprise also did put the no in innovation. So what do you see in terms of timing and the things that will drive what seems to be the biggest market opportunity, the enterprise, to actually to demand products in this area?
So is this a question about networking or cloud or automation or all of that?
All of it, but specifically then how it flows down to this networking discussion, because clearly you're starting to see innovation in the enterprise. People are talking about cloud, but it seems to be a bit of a gap before it really hits the kind of network innovation that you're talking about. And I'll also say there's kind of a correlator to that, which is programming 10,000 network elements whose internal state affect each other. I mean, you're from the HPC community. That's much more like a hard HPC parallel programming problem than it is just spinning up a bunch of stuff for the cloud. So I would also say that the analogy may have some pitfalls there as well.
Okay, fair shot. In the old days, 2004, 2005, we started with 16 x86 servers, and I can't tell you who the name of the company is, but that grid is now well into 6 digits in 6 continents around the globe. And so the thing that enabled all of that was cost. We were coming off of Silicon Graphics, we were coming off of Sun, and when you compare the orders of magnitude difference in CapEx and OpEx, business people who were our customers said, go try it. And so to make an extremely long story short, we went and built an external lab and went from 16 all the way to 600, did burn-in, did testing, and then went live. And so I can't imagine not taking a similar approach to anything new like enterprise cloud or switch automation. So not the first time it's been done. I see it as being more of a geocultural thing than a technology thing. So I'm pretty gung-ho, pretty looking forward to doing it. Hopefully by next year I'll be able to tell you more.
So all of this looks and sounds and smells great in a greenfield environment.
Yep.
Any comments on being able to use these technologies, this three-tiered approach with legacy infrastructure? Because you need to be able to use that core router, that switch that you bought 2 years ago over its planned life cycle. And I'm just curious, this is probably not something you address at the protocol level, but in terms of practice, what have been the findings?
Well, we're running it on our HP switches that we have bought over the last 3 years, in parallel with everything else. I mean, this is where the hybrid switch concept comes in, at least looking from the enterprise, is being able to enable OpenFlow on a per VLAN basis or per port basis and being able to start putting it out there in the places you want to play with it, but not touching the other things. So I think that's the key.
To kind of complement that, I think that that's what James Hamilton says, networking is the new mainframe. And I don't mean to be any anti-mainframe, mainframe is great technology, but you can't force fit something new into something old. If it's new, let it be new. I've had the exact same conversation with clients about Hadoop and big data and NoSQL. People bang on their desks, how come it doesn't have SQL compatibility? Why can't I use it with business object? I mean, it's different. And so a new class of problems goes to new stuff. And so not to sound like an optimist, I'm just telling you from 8 years of experience, when you have something that's a big CapEx and OpEx impactor, your customers will listen to you. And when you're talking about the kinds of savings I was putting up, they'll let you do it. So I think you have to be really careful. You'll always have your legacy infrastructure there. And to some degree, these are kind of sedimentary layers of IT. Mainframe never went away, mini computers never went. This stuff always still exists. It's around. It just diminishes and it kind of tails off. The new stuff is what gets the traction. The new stuff is where the growth comes from. That's at least from my experience.